almost all PGP encrypted emails are LARP. They're encrypted because, people feel cool encrypting it. They're like play acting. It's like a, Nerf swords version of whatever it is they're doing. Hello, and welcome to Security, Cryptography, and Whatever. I'm your host, Tom, with...
I'm Deirdre.
I'm David. Oh,
okay.
We did it at the wrong time. I'm always second. I'm always second.
I know, but oh well.
And with us today is William Woodruff. I'm a little wrecked. I spent the day moving boxes and bookshelves and furniture from my mom's office to clear out some space for her, which is a thing I would rather do than ever read a PGP email message, which is what we are here to talk about with William Woodruff today, the secure email ecosystem. And I kind of think we should kick this off with the reason we're talking about that this week, which is I think there was a bug. There was a bug this week in openpgp.
Yeah. Oh, it was an openpgp.js.
Does anyone know how it worked?
No.
No.
What? Malformed packet. It was a packet confusion of some sort.
I was not being serious. Do you three really not know how this bug works?
I really do not know how this bug works, and I'm excited for you to explain it to me.
You
Me
had
too.
one job. This is the thing we talked about that you were going to talk about. Oh my God.
No,
I read
you
the other
told-
things.
You told me to read the packet format, and I looked at it, and I was like, oh, cool, the new packet format's from 1998.
I think we should talk for a little while, for a very short while, about how PGP messages are formatted. Can I ask if any of the three of you know how a PGP message is formatted?
It's binary data that's been ASCII armored, and for some reason has a CRC checksum at the end.
Oh, if only that were the case.
Oh.
Go on.
This is the point where somebody comes in and explains why it's not the case. All right. So there's a blog post from, what is it? The name of it's a good find, Codian Labs. They deserve credit for this, right? So they have a vulnerability that allows you to spoof arbitrary openpgp messages as valid. And that message opens up with the claim that PGP has a relatively simple packet format, and then points to the RFC where they explain the grammar of the PGP packet format.
RFC 4880?
This is RFC 9580.
Oh, okay.
So an openpgp message is a packet or sequence of packets that adheres to blah, 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 the following grammar, which is openpgp message consists of encrypted message or signed message or compressed message or literal message, where a compressed message is a compressed data packet and a literal message is a literal data packet. It goes on and on like this in like a pseudo BNF thing. And any of these things can wrap any of these other things. So it's like an arbitrarily nested, set of packets, like, type length value packets.
And the packets have types, so this is like every network protocol has like a typed packet format. So why are we?
So this packet format has apparently been a nightmare for PGP implementers for like a really long time. There was like up until like I guess the late 2000s. Somebody's gonna call me on this, but it's somewhere around that time frame. There was a network of PGP key servers that everyone used.
Yep.
There was like a global internet key server network where you could register your keys. This is by itself a bad idea, and we'll get into why that is later, but it existed. It stopped
It's a bad idea
existing
because the way the keys are used. Like,
yes.
We have bulletin boards for certain kinds of keys. That is not the worst thing in the world.
Yeah, you're definitely right. And we'll get into like PGP as like a strata for like signing things, for like signing packages and things like that, versus for secure messaging, right?
Yes.
But like, so the thing that my understanding is that the thing that takes the key server down is a series of DOS attacks on the key server stuff based on packet parsing problems. Like there are ways to make the parsing of those packets go quadratic. So like you can send like, fork bombs of PGP packets. William is nodding, so I think William knows something, so I can stop talking.
Yeah, well, the main thing that I remember was, I think the big PGP key server explosion was in, I want to say 2018 or 2019.
Okay.
And that was because...
That's far too late.
Yeah, shockingly, I would say. And it was, it was trivial to make both GPG and other PGP backends. Not that there's so many, but the ones as well go quadratic on key parsing.
Which keys in PGP messages are themselves packets.
Yes. Yeah. I guess I'm using key interchangeably with what PGP also calls a certificate, but
Yeah.
which is a set of packets.
Right. So like it's. I was going to say it's easy to explain and just complicated in practice, but it's not even easy to explain, right? Because there's a grammar in 10.3 of that RFC, but then there's like 12 different exceptions to the grammar, and like all sorts of weird shit happens, and there's just no reason for any of this stuff to exist in the format, but it does. It's like a 1990s format that we still live with today, or some people do, right? And there was in openpgp.js a vulnerability in the handling of that format, and that vulnerability was you take a valid signed PGP message from anywhere, and you tack onto the end of it an additional compressed data packet. And that is the vulnerability. So the signature on that message for what preceded the message is valid. Whatever the hell you tacked into the compressed data packet at the end is not valid. It's just a random thing you slap to the end of the message. And openpgp.js returns the data from the unsigned thing that you slapped onto the end of the packet. That's the whole bug. The whole bug. Which is like, it's interesting, right? Because this is also like an XML DSIG SAML vulnerability type situation. It's kind of the same idea, or it's a similar vibe as what's called XML signature wrapping, where like in that format, there's this idea that like you have a single XML document, and like a subset of the tree of that document is the signature. And kind of the way that HTML has like IDs for like different elements in the document, right? Mm-hmm. The signature in that subset of the document has an ID that points back to the part of the document that's signed. Just saying this out loud, you can hear how fucking crazy this is, right? But that's how XML DSIG works, right? But like you sort of give XML DSIG you don't give it a pass. It's literally the worst format, like literally the worst format that there is, right? But like OpenPGP isn't XML. Like it's not supposed to have that kind of flexibility. It doesn't benefit from that kind of flexibility. It's not like an extensible grammar or whatever. It's not XML, but they managed to recreate the vulnerability anyways. Like a funny thing when you see like people in that ecosystem responding to this bug is just like, well, this is an implementation failure, right? Like, and it is an implementation failure, right? Only OpenPGP.js has this bug, right? But like, there's the obvious objection to that, right? Which is, it shouldn't be possible to have this kind of whatever. So that's that.
Like,
have you ever read OpenPGP code? Like my theory here, I did this once when I was trying to figure out like you can talk to like YubiKeys through some PGP protocol that's separate from PIV, and sometimes like that lets you do operations that aren't exposed in PIV, like curfew 5519. Mm-hmm. And so I was trying to understand like how OpenPGP did this at one point. And I went to grad school, meaning I've dealt with some like bullshit code that wasn't written by me more than perhaps in other situations. And PGP was scary. Like I could not figure it out, like for the life of me, like what the code even did, like not even like where it taught. It was very like 1990s C code. And I have a feeling that the packet structure is like downstream of some imperative C code that someone wrote.
Okay, because I was going to say...
And then like got back solved into some sort of packets format using whatever like style of writing C code was acceptable, popular, whatever in 1990.
Because I was going to say like...
Pre-K&R.
The format seems like it's like miserable and would lead to a miserable parser with all these exceptions and like circular, and like it's like the fact that you have nested like types, like it's a key but it's also a packet, but it might also be a certificate. Like I would think it would be the other way around, but I could totally see it being like no, we have code that resulted in a format, not a format that resulted in this gnarly parser code. I don't know.
That's my understanding of the history of PGP, is that the tail wagged the dog in terms of the standard. The standard came well after the set of initial needs were established, and so it just sort of grew out of that.
I don't think that's necessarily a bad thing, right? Like I think more standards should start, but like you want to start with something good.
Yeah.
Yes.
In their
And
defense,
usually-
it was like the 90s.
Yeah. I think the history, the process itself is justifiable. It's more the
Yeah.
timing is unfortunate.
Sorry.
If I recall correctly, like the early versions of like the .doc file for Microsoft Office was just like you just mem copied or mem mapped the struct that they used to represent a document in the program to disk, and then like mapped it, and this had obvious problems for years, and eventually someone solved it by introducing XML and docx, but like same story, I think, type of thing, where like the format, it's perfectly fine to do things without standards, but like if you're operating under the constraints of the 90s, it's likely that your format is like a little insane. It is not necessarily what it would look like if you know, built something without a standard that used a format today.
Yeah.
Yeah, I'm not sure we've ever like done a proper PGP takedown before, and there's like a lot wrong with PGP.
Yeah.
Like this, like the signature format is crazy. The way they handle authentication is crazy. Like there's all this crazy stuff in it. Like if there's anything like top line important to talk about there, I think like generally if you're kind of paying attention to us, I think pretty much everyone here mostly is written off PGP. Every time this comes up on a message board, I'm always like, please find me one cryptographer, just one anywhere, any cryptography engineer that works anywhere that will stick up for PGP. And I'm not sure that exists, right?
Right.
So like going through the litany of all the things that PGP does not get right is like, I don't know how super productive that is, but I think there's a more important thing, which is like PGP has two use cases, right? It is a package signing system for packages that people don't check signatures on. And it is a secure messaging system for messages that no one will ever care to read.
Or it's a way to encrypt data, but usually that data is a message, not like a file format. Although it is also used to encrypt like files.
Yeah, that's a fair point, right? So it's three things, right? It's the two things I said, and then it's also like encrypting files. And for like a very long time, a thing that really pissed me off was that none of the like Mac OS, for instance, doesn't have like a tool to just password protect and encrypt a file. But you have to download something to do that, which means that people, download like whatever the zip program is, and then that's like its own complete nightmare, right? And like for that problem, like you should use Age or Age or whatever, however you pronounce Filippo's thing in preference to PGP. But like the big problems with PGP aren't going to screw you if you're just encrypting a file, right? Like, I mean, I guess it has a really bad password KDF, so don't password, like use like
Oh my God.
use a random password or something like that, right? But that aside, right?
To the
Like,
KDF now.
Yeah, I can't remember what it was. I just remember that it's bad.
That's fine.
But like, so there's those three things, right? But like, I think the important thing to talk about is PGP email, right? It's more broadly any attempt to get email to be secure. And like, this is a thing that has been this is like the fifth thing in this conversation we're having where I've pointed out that something sets me off, right? But this one really sets me off, right? Which is like, so for obvious reasons, we are in a time period where we're reading lots of security guides for activists. It's a big problem. Lots of activists, doing important work and don't want to be surveilled, right? So you've got all these security guides, and there's two really big tells for me when I'm reading these things that like whoever wrote this was not super plugged in to serious kind of digital security stuff, right? Number one is when they uncritically recommend that people use Firefox. I'm fine if you have a well-reasoned Firefox argument, but if it just says use Firefox, it's open source, you don't want to be up in Google or whatever, right? Like that's a red flag for me because that's not that simple, right? But the other thing is any attempt to get people to use PGP for email, and you see this all the time. Like this is like a really big recommendation that people try to give people. Like they're trying to get people to do encrypted email, and encrypted email is bad. Can't be made to work.
Thomas, why is encrypted email bad and can't be made to work.
You can just disagree with me.
No. Tell me. I agree with you almost entirely. Please tell me, because I literally had to like scratch my brain and explain this to a normie the other day, and they were like, well, why is that bad? And then so on.
Well, I mean, I think David. So I was talking to Deirdre. I saw Deirdre's face, and then a blog post that I wrote like 5 years ago was in my face because she pushed the button. I think David should kick this off. Otherwise, it's just going to be me talking this whole time.
Yeah. Well, I think we should go through this blog post, by which I mean I will read out loud and pretend I am that streamer who shall not be named. This blog post called "Stop Encrypted Email." Stop using encrypted email. I already screwed up reading it.
No, you're reading it about as well as a YouTuber would read it.
Which Thomas wrote in 2020. I thought this was older than this. That doesn't seem right.
2020 before the world.
It has a timeless quality about it.
It does. But it began saying that email is unsafe and cannot be safe. The tools we have today to encrypt email are badly flawed. Even if those flaws were fixed, email would remain unsafe. Its problems cannot be plausibly mitigated. Avoid using encrypted email, which I think was just Thomas's point.
I think I write in a way that is difficult for people to read on streaming things.
Well, we're doing it.
We're doing it. And as Thomas noted, technologists hate this argument because few of them specialize in cryptography or privacy, but all of them are interested in it. And everyone wants to use encrypted email tools. I don't know if by everyone you really mean everyone, but I think you mean people who write guides for journalists online.
I think it's also nerd currency. I mean, I definitely, when I was a teenager, I was like, man, this is the coolest thing ever. I want to encrypt emails to my friends, which, didn't go well, but it was like nerd cred at the time.
I think technologists see like, I can make this work in the golden case, and you may be able to do that, but a lot of security and privacy is not the golden case. It's the average case, or often the worst case, and a lot of that comes down to kind of usability and like defaults of the whole system, which is not a technologist sort of thing. It's like a usability and design sort of thing, and that's not necessarily where our that has evolved over time with the tools that we have available today. And that was not part of how encrypted email came about, really.
Yeah, so we have like the LARP case that Thomas mentions here of what, William was describing of, let's send encrypted emails to each other because it's cool. And I set up this software. But then we have the case that Thomas refers to going on in which security does matter, because messages can be material to civil cases of discovery subpoenaed by law enforcement action, all that fun stuff, journalists, confidential sources.
Yeah.
And in this case, you have like actual harms coming where if the message leaks.
I think it's fundamentally true that almost all PGP encrypted emails are LARP, right? They're encrypted because people feel cool encrypting it. They're like play acting. It's like a, Nerf swords version of whatever it is they're doing, right? The subtext here is like, when you talk about how shitty encrypted email is, people are always like, well, what else are you going to use? Like, what's your suggestion, right? And if you like say Signal, they'll like, scoff or whatever, right? But like, the thing
Signal
is, like,
was created by the U.S. government, Thomas.
Yeah. I don't think that's true, but continuing, right? Like, so like, it always kind of boils down to like, like the choices are sending plain text email or sending encrypted email. And so you sound crazy when you tell people not to send encrypted email because it might go wrong. The thing I think people need to get their heads around is that those are not the only two choices, right? Mm-hmm. The more important choice, like the important third choice, is don't send the email to begin with, right? Like if you're coordinating a protest like thing or a direct action or something like that, like there are very good reasons not to trust any secure messaging system with those messages, right? Like that's OPSEC. And like almost all of the discussions about secure email don't have that premise. They all have the premise that the message has to get sent, right? And that can't be true.
I do think there are some systems deployed out there that are like, in our little email system where we control all the ends, we require PGP, we require, there's other things that are kind of like PGP, and that like you have a message encryption key that's encrypted under some other key, but it's all still like bolted onto email, and you can still send a plain text email, and it's really hard to enforce that in practice.
That stuff is all mostly S-MIME, which is like...
Yeah, S-MIME's different.
Separate Discuss technology, but like kind of same concept. But like there are ways to deploy S-MIME mildly effectively within the context of a single enterprise and get like...
Exactly.
Something maybe out of it.
I think most of these arguments will apply to S-MIME as well.
Yeah, I would agree with that. I mean, S-MIME is the basic flaws is present in both cases. The only difference is that S-MIME has the benefit of actually having a community, like a standards body. It's, I guess, somewhat serious.
And you can configure like most, I think, organization, like enterprise webmail now to be like, you use S-MIME and you have to use S-MIME for emails within my organization, and like here's the key server. Now, like, does that actually do anything? If like the keys are all escrowed somewhere else, I don't know. But if you're really concerned about the emails existing in plain text on the mail provider's server, you can understand why people might like this.
So you are thankfully giving up on the premise of just reading this straight through, which I appreciate, right? So, like, what I'm going to do is just introduce the first argument and then let you discuss and tell me if I'm wrong.
Okay.
All right? So my first argument, no matter whether you're using S-MIME or PGP or the secure email system of the future, you have this problem, which is that ultimately, if you're using a system that defaults to plain text, wants to send plain text, eventually you're going to send plain text, which is to say, like, everybody who's ever used PGP or S-MIME in anger, and at a security consultancy I ran in the mid-2000s, we used S-MIME for everything, right? Like, inevitably, somebody will respond to your message with an unencrypted reply, which will include your message that you sent originally encrypted. Everybody who has ever used secure email has seen this happen. This is a thing. If you're a journalist, or if you're like, organizing or anything like that, that can't happen. You're talking about like life and death there, right? And so the first reason that secure email is completely broken, right, is that can happen. Tell me if I'm wrong, or or commiserate with me.
I think of this whole blog post from 2020, this is the strongest argument. And this was also the argument that some people had about the old school variant of, I think it was Signal when it was text secure, which was like, it was encrypted chat over SMS. It was using the best, ratcheting cryptography on top of the SMS messaging protocol that was in the clear, visible to your mobile provider messaging protocol to start. And that it was definitely like, be careful, you can send a end-to-end encrypted chat message on text secure, or you may, if you are sending it to the wrong person, you may be sending it in the clear. And this is also kind of what happens in my iMessage to this day, which is like you use one client to send a chat message, but you may or may not know that going to the non-iPhone receiver phone number, it will be in the clear. And if it goes to the iPhone receiver or iMessage receiver, it will be end-to-end encrypted. It's an unfortunate failure mode for like Signal's way, like years and years and years, has been all Signal clients are end-to-end encrypted. There is no accidental sending of a Signal chat message or WhatsApp chat message after they migrated their entire client base to end-to-end encryption. They originally were SMS. They were in a nice space because they were SMS, and then they migrated the whole thing to end-to-end encryption, whereas Signal in the very early days was kind of this, possibly both case. But that is impossible with Signal now. Everything is end-to-end encrypted by default. That is impossible in WhatsApp. Everything is end-to-end encrypted by default, even though it has a little bit less metadata privacy than Signal. That is not the case in encrypted email. You might have SMIME, you might have this PGP, you might have everything nicely done correctly. The protocol is still a default plain text protocol. You are layering this extra crap on top of a default plain text protocol, and it's up to you to never fuck up. Like, what is it? You have to be perfect all the time. The adversary only has to get it right once, something like that. Or you have to fuck up once and the adversary just has to catch you. That's the case for trying to make end-to-end encrypted email work. And we've learned those lessons of why this is bad in other places for secure communication. And it just doesn't seem like we're ever able to make it work with email. Signal, WhatsApp, all these other iMessage aside, they aren't on top of the default plain text protocol anymore. They completely moved away from it. Email is still plain text by default. So I think this is the strongest part of your arguments here.
Yeah. I think kind of a funny thing that keeps happening is every once in a while, someone who defends PGP will bite the bullet on this, and they'll say, well, what we'll do is we'll control the client, and we'll force the client not to send plain text responses. And that gets to the argument that I've seen Thomas make before, which is that, well, if you're going to do this entire thing where you build the whole ecosystem around PGP such that you can't use PGP wrong, why not simply do the easier thing and not use PGP, given that you're going to break compatibility anyways?
Yeah.
Yeah, like I know, like that's like the Delta Chat thing. Like I haven't really looked too closely at what they do, but their whole thing is they claim to do. They're the ones who finally done it. They finally cracked the code on encrypted secure email, but they do that by totally breaking the compatibility assumptions in email.
But I mean, the one thing, and that like you do that, the one thing that you are retaining from email is the possibility of being compatible with somebody who won't encrypt their messages. That's all you've saved.
Well, also like the sending of messages solution. Like, I think people they want to use the thing that already works, which is like the modality of sending emails, but they want to do it securely. And so it's so, I can see it being so easy to just be like, well, we just don't send emails. It looks like email, smells like email, but it's not email. But then people are like, well, why can't I email this person who uses this client that it's supposed, it's not secure, it's not set up to take my end-to-end encrypted email, and then you're back at square one.
Man, I would love it if I couldn't accept email from people. So
there is that subtext.
I think there's a lot of like I think about this a lot with protocols in general. There's a lot of like nerd pattern matching. People love the username at domain scheme for things, and I think email in that sense is very comforting. And so the idea that you can do encryption on top of that is especially comforting.
Speaking of the thing that users love about this, which is the username at thing, right? My second argument, which I think might be stronger than the first argument. So I'm waiting for you guys to tell me I'm wrong about this. Right? The second argument is for a serious adversary, if it's a state level adversary or whatever, the metadata surrounding the message is often, maybe even usually, just as valuable as the message itself. Right? What they want to do is roll up the network of who's talking to who. They're probably starting from a point where they've got like some particular person or contact that they know they're targeting, and they're just trying to work out what the network is, like who they should like expand surveillance to and all that, right? So metadata, super, super important. And email doesn't just like leak the metadata. Email like proudly publishes the metadata. It's a store and forward system where every time you send a message, no matter what you're doing to encrypt the content. The funniest thing about this whole thing, by the way, is that PGP email doesn't encrypt the subject header, which is like the subject header isn't even metadata. It's just message, right? It's just part of it's the summary of the message, right?
I hate this
but
so
that
much.
aside, like the to and the from of that message and that graph that you build of who's talking to who, like this is the entire reason why Signal asks for your phone number is so that they can draft off of your local contact list and not maintain a server-side contact list. Because if they had that server-side contact list, somebody would eventually, target them for it legally or otherwise and get it, and then have the entire graph of everybody who's talking on the service. By the way, if you use like a secure messaging system where like you go from device to device and you just automatically have the complete contact list everywhere, you should ask yourself how that's working, right? Because if the way that works is that they have a server-side contact list, they're keeping the whole graph of who's talking to everybody, like server-side, just there, right? Yeah.
The iMessage and Apple like migration tooling, and now the Signal migration tooling from device to device has like become very advanced to avoid this scenario in particular. They literally take everything on your device. You do a little bit of a Diffie-Hellman handshake to make sure that you like do a daisy chain of auth, and you're authorized to move things from an old device to a new device. And they go from device to device. There's nothing going up in the cloud really, other than like I am registering a new device, like at timestamp. Like that's kind of it. That's going from device to device. If you're not doing that kind of like, kind of little dance protocol between devices and things just show up on your new device, it's because it's up in the cloud. And maybe there's some sort of password and maybe some of it's encrypted or whatever, but going from device to device and not going up through somebody else's computer is, less risky and less exposed. The other part about the contact list being like public and available and subpoenaable or hackable or whatever, Signal's done a lot of work to like keep as much metadata about who's talking to who's in what groups, what the groups are about, the profile pictures and aliases and nicknames of people in groups and between people, completely encrypted and private and not accessible or visible to Signal the service. But that has involved a lot of advanced cryptography that no one else does. WhatsApp doesn't do it. A lot of these advanced, end-to-end encrypted messengers that aren't super popular yet, they're not quite there yet either. Signal has done a lot of work, and that was definitely not available when they were kind of up and coming. And that's like why the bootstrapping of your local contact list of, phone numbers in your phone, which is just on your phone and does not get uploaded and none of that, that occurred, and is sort of like the historical legacy that's kind of inherited into Signal. Doing that syncing privately is a ton of work, and Signal may be the only encrypted messaging service that could do it, and they're still not doing it because it's very difficult.
Like, it's going to sound, I think, a lot here like we're just boosting Signal, and like really just use anything but email, and I don't have this much of a gripe, right? It's just email's the problem, right? Use Matrix. That's fine. I have I have things to say about Matrix, but I think Matrix is generally a well-intentioned and heading in the right direction project, right? Like there's lots of different things you can use. Just
Mattermost.
You should, I guess, Mattermost.
I think also the email argument, or the metadata argument with email, is that email is uniquely profligate with how much metadata it encourages everybody to use. Like all the email clients have emoji reactions now, and those are in metadata, and those are also part of the message semantically now in metadata. And so now people, I think, probably don't realize the 5 people who both use PGP and emoji reacts in Gmail are setting clear text emojis.
I hate that. And I love emojis.
Do we know this is you're breaking news here? This is so. How does this work? So these are like MIME headers that get attached to the message?
They add. I can't remember what the Gmail one is, but the Microsoft one was like XMS React or something like that. And then it's. I would have to look up the exact details, but it's like
you can just off the top of your head this. You don't actually have to have it right, but is it like a single line base64 header, like an actual header?
It's an actual header. I'm pretty sure it's an actual header.
I can imagine like a MIME section, right? Like you do the whole like the messages like this set of MIME packets or whatever. I believe you when you say it's a header. I just think that's crazy.
It may also vary by email providers. This is the thing that is concerning me, is that I think what I'm saying is correct possibly for Outlook. It might not be correct for Gmail. Gmail may do the MIME thing.
Oh.
But I am trying to actually find this documented somewhere.
I hate this so much because emojis are content. They are the body of communication. I mean, you can have an entirely like important, very sensitive conversation just in emoji reacts, because I've done it. I've done it. On the argument that metadata is important as content, it really depends. Like it's important to protect it. It's also difficult to protect it. The emoji reacts not being counted as content is just wrong. But like the metadata about who is talking to who at what time and like how long the conversation is and things like that, the subject line, that is content. That should just be encrypted, and the fact that it's not is ridiculous. But the other stuff, it's hard to protect it because a lot of it is like control flow. Like how do we route information? Even WhatsApp doesn't encrypt this stuff. They know who is talking to who at what times and things like that. Signal has done a lot of work to not be able to detect a lot of this, but it got better at it over time. And the stuff that's subpoenaable from Signal is literally like the time that someone registered an account, like the very first time, and the last time they contacted the Signal service. Like they've very proudly put up their, responses to, subpoenas and court orders about like, give me information about XYZ users.
Right.
But even if you get it, I think there's like, this has been kind of the evolution of what you can get from devices if you just try to give me access to devices. If you can get access to devices, there's a lot of content, including previously securely communicated end-to-end encrypted content on devices or on clouds, especially like iClouds that are not fully encrypted backup, or other cloud backups that you might be able to get access to. And that's really rich. And if you can get access to that, that's really good stuff. If you can't get access to that, the metadata is useful, and especially if you're trying to spider out from a target. If you're trying to find more people in like a communications network and you're trying to find links, I do think it's important. I don't quite agree that it is as important as content in the year of our Lord 2025, because there's just so much content available out there from random places, whether it's the cloud or, just give me access to your device via some sort of like court order. Or if you want to be really, targeted at a specific person, you can try and like target their devices specifically and send them, an attack, depending on the security of the device, and get everything, quote, like effectively everything. So.
Right. I think that those are all totally valid points, right? Like, I think the thing I'm trying to call out about the unsalvageability of email is just, if you think about how email works, right? Like, there's so many places where you can do a dragnet and just collect all of the metadata going through like a message flow for a bunch of people, right?
Yeah.
Like
that's
every
true.
MX hop, whatever, like they're just, the processing of these emails leaves a log trail of who is talking to who, and not just on the one central place that you could potentially protect or whatever, but just like everywhere that the message goes, just like leaving this trail. It's also like, to me, like another important thing here is just that governments are already really good at accessing this metadata. They understand SMTP metadata, right? Like for a long time, there was a thing that got passed around about like, for each of the different messaging services, what could the FBI access? Like which things could they actually use? And it's like with Signal, it was like, that you use Signal and then nothing else, right? But like, the amount of stuff they can mine out of SMTP metadata, I think, is a lot more than they're ready to get from anything else.
Yeah.
And like every client just like rebroadcasts all the metadata from their perspective at every step. And that's like how the protocol works, right? You include all the parent responses. You say exactly who you're responding to and why, and like the chain of how you got there. And then the provider signs every message to make it clear that the metadata is like real, because everything via what's that, dkim
is anti-spam.
Yeah, because everything that we had to build for spam is all about like authenticating allowing servers to authenticate the metadata to each other.
Can we do like a 1-minute thing about how you should never take any kind of security advice from anybody who says that dkim messages should be authenticatable, and like that it's a bad idea to burn dkim signatures? This is very definitely a thing, right? There are definitely, like, this is how like the Hunter Biden messages got authenticated. Like they were published with valid dkim signatures, and it's like you respond to that and say like, well, we should burn the dkim keys so that you can't really authenticate them.
That's how we fought the deep state. We would never be able to fight the deep state without dkim keys.
And it's like people will say things like, well, no, we need to keep these dkim keys secret so we can authenticate messages because that's how we'll do journalism, by like authenticating people's leaked messages. That's like, you're the adversary. Like you are being the adversary right now.
I mean, leaking them on the scale of like, rotating them every 1 month to 6 months or whatever, and then like publishing the old ones, I think. Yeah. I don't think we should stop authenticating messages at time of send, right? Like, I, for one, enjoy that my inbox is only like 50% spam and not 95% spam.
Yeah. And like 50% spam is like stuff that I signed up for once upon a time and not like boner pills are us or whatever.
Speaking of new sponsor.
If you do want to sponsor us and you are not Boner Pills R Us, we're trying to hold an event in Las Vegas during Blackout at DEFCON. Contact us at securitycryptography.com. Are we .com? .org? I forget.
Me. Just contact me. Figure it out.
David's the one that handles this. Just
if you send me a PGP email, I will not respond. After I defended my PhD, I sent a number of people thank you emails, and then one person responded to mine with a PGP email, and to this day, I still not have read it.
Yeah. This is the way that it stays secure, is when you do send the encrypted email, no one will ever be able to decrypt it, and so that part stays secure. This is all this metadata discussion is reminding me that one of the pros of email, of SMTP, is that it is federated. That is why it's part of the reason it's leaving this metadata trail like all over the internet. This is like a thing that some people like about the protocol.
I don't know that I would call it a pro that it's federated. I would simply state that it is federated.
I have a bigger thing here, which is just, okay, so it's federated and people might or might not like federation.
Right.
This is like a long time thing with Signal. Like Moxie wrote a whole thing about why they weren't federated, which really set people off, right? And like, I feel like he was utterly vindicated on that after what happened with Matrix and their attempt to convert from non-encrypted to encrypted. But there's a deeper issue here, right? People complain about federation. Maybe that's a colorable argument. People complain about things being open source. Maybe that's a colorable argument. People complain about running too much stuff through Google. Maybe that's a colorable argument. But none of those arguments are about security, right? If the premise is we're creating a transport for messages that are life or death sensitive, then none of that can matter. It can't matter whether or not if you are talking to an activist community, especially if you're talking to an activist community in some other country, but increasingly in ours as well, right? If you're talking to people who are like organizing to protect immigrants from ICE, for instance, or something like that, right? And you tell them to use PGP email because the alternatives are not open source or federated enough for you, that's malpractice. It's literally malpractice, not in a funny way, not a dunking way. Like, you are committing professional malpractice, right? You're putting people at risk to serve your weird goal of needing a federated or open source or non-Google transport. And that's fucking crazy. Like, I don't understand why people's jaws don't drop when they see people saying this stuff out loud.
I think this is now getting into like the crank side of the world, but like, I think people sometimes just don't believe that things are actually end-to-end encrypted, and because they don't believe that, they then believe contrapositive things like it should be federated. Like, well, if they're not going to end-to-end encrypt it, then I might as well do the federated thing. And this is obviously wrong to me, but I think this is why we get into these weird online arguments as a community over and over again about this stuff.
Yeah.
Like, yeah, the set of people that think the Signal has a backdoor there because it's centralized, or because Moxie wrote a blog post they didn't like, or because they think the CEO is like too whatever.
Yeah.
My next argument. This one is, I think, more small ball than the first two. I think the last one, there's 4 of them total. The last one gets us back to kind of, grand theory stuff. This one's really specific, right? Which is, everybody who uses email has an archive of their email messages, which is a thing that secure messengers deliberately go out of their way to not have, right? So I can go and search through pretty much every email that anybody's ever sent me, going back like a staggeringly far, back time in history in my Gmail account, right? So all of those things will eventually somehow leak. Like every day that you hold that archive, you're incurring some kind of risk that it's going to leak. It's just inevitable that at some point it has to, right? So there's no plausible mechanism for doing any kind of disappearing messages in email. And I think like that's not like the most super interesting, fun technical topic to talk about because it's really simple, right? But I think it might be pretty important in terms of actually impacting people's safety. Just the fact that you can't like set a maximum amount of time for a conversation to live.
Yeah. I think that's actually like the most important feature for like, quote unquote like secure messengers for like non-activists as well. Like even iMessage, like you can, if you go into settings, you can set your iMessage to delete after like 30 days, but it's like per device setting.
Oh, that's
so
annoying.
you can end up with like iMessages that are on one device from like, I just saw some that were over like a year old on this, on this laptop, even though I have it set to delete after 30 days on my phone. And that's not because like it's a life or death scenario or because I'm an activist, but just because I'm like, I don't want these messages like, I just don't want old shit to like come up and bite me regardless of what it is because it's old and like, oh, remember when, David cheered for the wrong football team, right? Like, even shit like that. Like, it's just like, no, you don't want that to come, to just like somehow get screenshotted or whatever, right?
I like the idea that at some point in your past you cheered for Ohio.
No, I cheered for Michigan State for like a small period of time when I was in high school, and my brother was a student there before I had the good sense to become an engineer at Michigan.
Yeah, like I'm in Gmail right now, and like Gmail's not, I don't know, a full, it's a web client. It has other, desktop clients, but like there's no option for me to just like automatically delete things at any age. Like I can throw stuff in the trash that requires me to take an action, and it will auto delete stuff in the trash. But like, yeah, I've got thousands and thousands and thousands of emails from many years and then I've got multiple email accounts.
And like a comeback you can imagine is somebody saying, okay, well, they'll just add the feature, or you'll use an email client that has that feature. But that's actually not the feature, right? The feature is the protocol accommodation where you can communicate to your counterparty that they should also delete these messages, which is something that's like you could write a Signal client that didn't honor that message, but no one's going to use it, right? It's the fact that the protocol it's an accepted feature of the protocol, which it will never be an email.
That's not true. Pete Hegg successfully used that Signal client, but other than that, no one will use it.
PC small group. This is sort of like one plus in the kind of the Moxie no federate argument that he made, and we're linking to that post in the show notes. Where
on the off chance you're listening to this and you don't know who Moxie is, he is the creator of Signal.
He's the primary creator of TechSecure, and oh gosh, I forget the name of the calling app that then got merged into the
Open Whisper systems. Open Whisper.
The original
Red Phone,
the original
I think,
thing
was the app. TechSecure was the texting app, and the company was called Whisper or Open Whisper.
Gotcha.
Yeah, it was Whisper System, and then they were involved with Twitter long ago.
Yeah, they got acquired
and then,
by Twitter somehow.
Yeah, and then like he made the new Open Whisper Systems, and everything got turned into the Signal app and the Signal service, and everything is like GNU licensed and open, but it's a copyleft license, so you gotta talk to. Yeah, well, you can look at it, but like, yeah. So you could run it if you wanted to. Everything's there, but you can't. Anyway, but because everything is controlled and not federated, they control all the clients. They implement them themselves. They're able to update and move the protocol forward because they control all the clients, and they're able to move faster. And they were able to make automatic deletion and deleting messages for all the parties, all the clients in a chat, for example, a thing. And that's so much harder to do when it's like an open protocol, such as something like SMTP. Like, you can do it, but like, do you have the guarantees in practice that that is going to be implemented honestly and correctly? When it's an open protocol, like, okay, yeah, you may have like a must in this, like, delete this message packet header or something like that. Delete after, T plus 30 days according to your local clock, or delete in 24 hours. And like, as I think we all know that, like, you can put all the musts and musts nots in your protocol spec as you want, and like, people may do their damnedest, and sometimes issues happen, and sometimes you fail, and sometimes there are bugs, and sometimes there are bugs in client software when you control all the clients. But generally, it is less likely that you will have implementation skew and bugs between independent interoperable implementations of something like a delete me flag on a message when you control all the clients. And there's only like 3 of them. In the case of Signal, there's the iOS, there's the desktop, and there's the Android clients. That seems like less of a thing that you can do on a protocol like SMTP. Although I'm very curious how MLS-like protocols will do this, but it just may be more of the same, of like, try real hard.
No one uses MLS to like interoperate, aside from the one obvious example. Right?
Well,
like,
they really want to.
Can implement disappearing messages by implementing disappearing messages, and they happen to use MLS with other WebEx clients.
Europe is really incentivizing people to actually make it happen.
Yeah, I mean, a key part of this is not even a cryptography thing. Like, you can't cryptographically prove deletion. This is purely a protocol and application design matter.
Right, which makes it interesting that how intractable this is for email, right? It's not even like there's a theory issue for it. It's just like, you'll never get something deployed where you can reliably tell somebody else to delete an email. So,
yeah.
Last argument. You guys ready? I think we're ready. The last argument: long-term secrets. So eventually any secret you hold will also leak. This is the forward secrecy thing, which is like, forward secrecy, if you're talking to people, like, I'm imagining, I do a lot of local politics, and every once in a while I'll get asked about secure messaging stuff from people who are not computer people. And I'm trying to imagine explaining forward secrecy to somebody who is not like, because it's not like, it's the worst term. Right? Because it's like, It's not about secrecy going forward. It's about secrecy going backwards, but it's called forward secrecy, right? So it's just the idea that every solution that we have for secure email is based on static long-term secrets. There's no such thing as an ephemeral, email secret exchange, which means that, everything is kind of tacked down, like whatever, if you're, having ongoing conversations with people, at any point, if that secret leaks, the entire backlog of everything that you've ever sent is also going to leak, which is a complete own goal, right? You don't have to have that problem in a serious messaging protocol. You could fix that with ephemeral key exchanges. So I think that's also a really big point.
Yeah. And this is fundamentally like both how SMIME and PGP-based encryption schemes work. Is you have a encryption public-private key pair. You push the public key onto one of these key servers, these bulletin boards, and then someone will usually encrypt a message encryption key to your asymmetric public key. It's a symmetric encryption key for something like AES, and they encrypt it to you under your public like RSA or REC public key encryption scheme, and then you decrypt the key with your private key that goes with the public key, and then you decrypt the message with that secret. But this is still protected by one key pair that you use over and over and over and over and over again. And so while you have a different key per, say, message or whatever it is, it's still all fundamentally protected by the same key. This is not how it works in Signal or WhatsApp or MLS or possibly Mattermost. I forget that protocol. This is just not what modern encryption messaging protocols are like. They do a new key establishment for every message, and then mix in information from when you set up the session that kind of that binds to identities to a little bit. You attest that you are who you say you are and that this is linked to previous messages. But every message is computed differently so that if any of those previous things leaked, if any pieces of these things leak, like you're safe. Like the previous things are safe. The future things are kind of defunct, and like depending on how the protocol is implemented, it can self-heal. If you have an honest protocol and you kick out the leak of the adversary or whatever, it can heal, and then you can get back to that same security level of independent messages, having different key material. That is just not how it works with BGP email. Or yes,
William,
fine.
I'm going to read you something, and you're going to tell me when you know who the author of this thing is. Don't tell who the author is. I don't want to.
Okay.
But you'll tell me.
I know who it is.
All right, here we go. Forward secrecy is somewhat overrated in end-to-end encrypted
already know who it
messaging.
is.
Most people do not want a truly off-the-record experience, but instead keep their messages around indefinitely. As long as those old messages exist and are accessible to the user, they'll be just as accessible to any attacker who gets access to the secret key material. The Signal protocol somewhat excessively provides forward secrecy for each and every message sent. This is sort of pointless while the messages still exist on the screen.
I knew after the first sentence that you still don't want me to say who it is, or
No, you can in the abstract.
okay. This is one of my favorite people on the internet. This is who it is. Someone who I've talked with many times, or rather, I don't even talk with is maybe not the right way to say it. Exchanged missives with.
He does a valuable service, right? So this is a commenter on Hacker News who is like the designated defender of PGP, right? And like, it's actually pretty valuable, like having like something like this be written, because it forces you to kind of refine. Like he has a whole spiel about why authenticated encryption is not always good, which is like I can't even remember what the argument is, right? It's hard to get your head around. Like, it was something about like recovering corrupted messages. Like what most users want is messages where if there's like a bit flip failure or something like that, they can like recover it or something, and authenticated encryption makes that break down or something. But it's like having to articulate why, of course, you need authenticated encryption everywhere is actually kind of valuable. It's just the amount of like back rationalizing you have to do to keep PGP like kind of in the story.
Yeah, and he has a couple of posts that are not like inherent, or they're not entirely nonsense. Like he has one about like 2048-bit RSA, like. It's fine, is I think the point of his argument, and it's like, is it good? I would say it's not good. To me, I would do a default bad no for any RSA, but like, is it the worst thing in the world? No.
Like there's strong arguments within like the proper cryptographic community about how big these parameter sets really need to be. Like a lot of them are arguments about symmetric primitives, like some of the new stuff that's based on Ketchak. If you want to look up Too Much Crypto by J.P. Almanson, he makes some nice arguments about the bounds that we need in practice against known adversaries and the best known attacks, so that we can arguably get just as much security with smaller parameter sets, blah, blah, blah. I don't know if that applies to RSA 2048, but there are good faith, well-founded debate about other cryptographic primitives and sizes and things like that. Arguing that like you like just don't have good forward security or post-compromise security just because you don't really need it. That's fundamentally just like giving so much power to a possible attacker of just like, again, they only have to be right once and you have to be right over and over and over again. And having these forward secrecy and post-compromise security protocols make it so that the adversary basically it gets reset almost every time you send a message, practically. It just makes it a lot harder for someone to just, take all the public information you're sending in these ciphertexts and like get a good crack at like the whole session.
If you assume every via Thomas's, I think, principle 2 was that every PGP message ends up getting sent in plain text anyway. You don't need forward secrecy then. because it will simply leak.
So there's a kernel of like a useful conversation in that argument that he has, right? Which is like, people are going to keep their messages around anyways, so what does forward secrecy matter? And it's like there's some truth to like, I have an archive of emails going back to like whenever Gmail started, apparently, right? Like, and I don't care. Like, I'd rather have them around than like OPSEC them out, right? Like when I just don't use email for stuff that would matter for, right? So like the thing to note here is like, it's fine to say that email is fine for some kinds of conversations. Like it's fine to say that, like, I'm not saying don't ever use email. Like, use email. That's fine. I use email for all sorts of things, right? Just don't use encrypted email. Don't try to send secure emails to people, right? We get in trouble when we try to make this one system that we all like serve life and death use cases. And if you can't articulate a threat model, like first of all, if you don't know how to articulate a threat model, but like if you can't like just rattle off what the different threat models are for people protecting immigrants from ICE versus people chatting with people they met on Hacker News or whatever, right? Like, then you shouldn't be giving people advice, right? And this brings me back to just like digital security guides for activists and things like this, where there's clearly no threat model in this stuff, right? Like, it's not based on an understanding of who their adversaries are. And what's really frustrating about that is the real advice is not that complicated. It's not like this is just not like we don't have the sophistication that we need to give people good advice. It's just you need people to just be able to say, like, just use Signal. Right? Forget about all the politics of it. Forget about like whatever you think about Moxie, Marlin, Spec, or Federation. Just use Signal, right? Probably don't use Firefox. Just things like that. Which again is just like this whole thing right now for me is just my red flags for digital security guides. One of them being anybody talking about PGP.
Yeah, and like number one for me, a lot of people, when you're making recommendations of like how to achieve digital security, trying to achieve a goal, you're trying to organize, you're trying to keep your team secure, you're trying to serve some community. It needs to be easy to use and easy to get right. It can't be make sure you use super special client. Oh, it might not be available on this phone. Oh, like you have to make sure you tick this box, you have to add this extension, you have to do XYZ to make sure that you use it right. That's bound to fail. One, it's bound to fail because it's hard to get right, and so you might actually get a security failure. Two, it's a lot of work for people to do. If the alternatives are download Signal, we will add you to the chat. That's so much easier to do, period, and get right because you don't have to do a bunch of extra steps to get it right and achieve better security. Yeah, I feel like a lot of people are just trying to, they have their values and they're trying to say, oh, you should do XYZ because this aligns with my values, as opposed to people trying to achieve something in the real world. And if it's too complicated and it takes too much work to achieve good security, they're not going to do it, or if they try to do it, they will fail and they'll open themselves up to a vulnerability. And then what's the point of the technology in the first place? One thing I kind of wanted to point out is like, oh, if you've got an archive of all your messages forever, and theoretically your messages will just leak because they're around forever, and so what's the point of forward security? And like, one, it's a belt and suspenders things. It's the Swiss cheese approach of security and systems. It's not any one thing. It's if you don't have forward security, you are more vulnerable to one of these things going wrong, an adversary, pwning one of these keys or a key server or whatever it is, one of these keys, and then everything falls apart. But if you don't have a giant message archive, like, the blast radius is less bad. And like, if you don't have all this metadata, then like the blast radius is less bad. It's all of these things together are pretty fucking bad. If any one of these things was less bad, then it would be less bad. If any of these things were less bad together, we probably wouldn't be talking about this at all. But they are all pretty bad together. So the forward security, just don't try to do encrypted email. Use Signal. Use WhatsApp. Like, some people don't like WhatsApp for reasons. Using WhatsApp is way better than trying to use encrypted email, in my opinion.
Yeah.
It's also like the only way to talk to people in Europe.
Yeah.
I was blown away by that. Every time I go somewhere that is, especially in like Southern Europe or in Africa, it's like people will just message me randomly on WhatsApp. I will have no idea who they are, but better than anything else possible. It's awesome.
Yeah. Use Signal, use WhatsApp. If you need to encrypt files.
Use Signal, use Tor.
Yeah. If you need to use Tor, install the Tor browser. Yeah, and you're done. It's based on Firefox. It's a pretty good browser.
Didn't we just
What?
tell people not to use Firefox?
Wait, hold on. William, are you going to respond to this, or am I?
No, you're
Actually,
gonna do it.
I think
I
Brave
can't,
also
I can't tell
supports
if you're
Tor
just trying to make
too.
my brain pop.
Sorry, but the Tor
did you
browser.
Just not ironically.
The Tor browser is like everything's set up, everything's good to go, and I think the other options are less tailored. But sorry, yes, I said that.
I'm guessing for reasons that you're probably familiar with Dan Guido's argument about why the Tor browser bundle is the literal least safest browser to use in the world.
I definitely have heard him make the argument before. I can't remember off the top of my head.
So it's a combination of things where it's like, so first of all, you're using Tor, right? Which, like, from a traffic analytic perspective, you can see that somebody's using Tor, right? You're using Firefox, which is the least secure of the mainstream browsers, and you're using a fork of Firefox, like a tracking fork of Firefox, and you're collapsing all of the Firefox vulnerabilities down to a very small set of Tor browser bundle targets. So like the exploits that you need for that, like you like a serious adversary needs like a battery of exploits for like all the different versions or whatever they're using, but they don't need that for Tor browser bundle people.
Yeah, I've definitely heard him make that argument before, and I find it convincing, especially for. I think it was especially true maybe 10, 12 years ago when the state of Firefox container isolation was really, really bad. It's been a long time since I've looked at browser security, and so.
Yeah,
I would say Firefox has come a long way, especially in terms of sandboxing and a lot of memory safety integration into the whole stack. I think arguably Safari is less good than Firefox at this point for some of those reasons. But yes, if you're using Tor browser, you are a little bit sticking out in terms of, fingerprinting and all that sort of stuff. In terms of, I don't think we're really telling people you should use Tor. We're mostly doing the meme of use Signal, use Tor. And if you want to use Tor, like downloading the Tor browser and just using it is like the easiest, straightforwardest way to do that. But just never mind.
It's not a super strongly held opinion of mine. It's just it's an argument I've had beaten into me by Dan Guido and the Grok.
But if you use Safari, you get to use the best named mitigation ever, which is the Giga Cage.
The what?
The what?
The Giga Cage.
Giga Cage.
Yeah.
I want to Giga Cage.
This is my favorite mitigation ever added to a browser, which is people kept using array buffer for exploits instead of Safari. And so what they did was they put the backing store for all of for array buffer into a m-mapped 4 gigabyte heap region, and then made all offsets 32-bit. So you just can't escape that region.
Huh.
This is a Dan Kaminsky idea from like the mid 2000s.
Oh yeah,
this was like his big memory safety thing was 64 bits.
Yeah.
This is also how the V8 sandbox works as well.
Really?
As it's a little part of it. So like the V8 sandbox is a little more than that, but to make the memory regions work, they have a variety of slightly larger than 4 gigabyte regions that are only addressed in 32 bits. You can't get off of.
Cool.
In theory, but like then there's a bit more to it.
There's always
as well.
yeah.
We're only going to find out over the next 20 years that Dan Kaminsky was literally right about everything. Just in like subtle ways.
If someone has one of those Wall Street Journal dot profile pictures,
The stipple painting?
Yeah.
the stipple painting, that just makes you correct about everything.
I was wrong to doubt the stipple painting.
Rip Dan Kaminsky.
Yes.
All right, so
I think that's
I'm
it.
gonna go.
I think we covered it.
I'm going to go install some random ass PGP extension in my browser, and I'm just going to start sending the wrap up for this recording with an encrypted email. I hope you love
Make sure you use Tor browser.
We will ask the armor the episode notes.
Yeah.
I wanted with cast flag, the official Canadian block cipher.
And apologies to the person who sent me that PGP email on the off chance you're listening, because it's kind of identifiable.
Maybe it was a really mean email.
Could have been. Who knows?
All right. Yep. If you can, stop using encrypted email, and stop telling people to use encrypted email. It's just not good in our opinion.
Good note, Deirdre.
Yeah.
Security, cryptography, whatever, is a something of
Side project.
It's a side project of you, me, and David.
Yeah.
Exactly. And our editor is Nettie Smith, and we sell merch at merch.securitycryptography.com, and we thank you for listening, and we thank William for coming on this episode with us.
William, thank you very much.
Thank you. Bye.